Okay. So this is a BC question from 2013, number 5. Again, another differential. I'm going to post this both on the AB Google Classroom MVC. AB, this is BC only, part B. Okay, the rest, both classes can do that, okay? So for this question, all right, they give you this differential, they give you initial condition. First question is to find the limit as x approaches 0 of this function. So remember, the first thing that you always want to do is plug in okay, so when you plug in, this is going to give you -1. The way I'm getting that from here, right? F of 0 is -1 plus 1 over sine 0. Okay, so this is 0 over 0. So remember, a limit does exist, right? And we need to do work. All right, so when that happens, right, L'Hopital's, right, meaning that you're going to take the derivative of both the top and bottom, or numerator and denominator, so f prime of x over cosine x. Okay, now again, if you plug in 0, denominator is going to be 1. Now, how do we get the derivative? Okay, well, we know f prime of 0, right? You're going to plug in 0 into the derivative, okay? But one thing is, what would our y value equal in this situation, right? So if you're plugging in right, you're going to plug in 0, you're going to get 2 times, let's see, right, so my derivative here, so going up here, right, so x is 0, y is -1, plug that into your derivative, so you'll get -1 squared times 2, because 2 times 0 is 0 plus 2. So this gives me a 2 as my limit. Okay. All right, the next part, right, we're going to do Euler's method. Okay, and I still want to use the function that we have. Rewrite it. And we're going to still use that point f of 0 equals -1. So again, when we're starting at 0, okay, let's set up our chart. So you have x, y. So in our first one, you have to go to that point, right? So you have x, y, and we want to have the same steps to get to 1/2. Okay, so in this case, delta x is going to equal, if I have to get to 1/2, right, I'm going to have 0.25 for my 2 steps so that I could get to 1/2. Okay, so then the next thing we want to do is find our dy dx, right? So you're plugging into this equation here, okay? And so that first one should give us, let's see, so -1 squared, so it's going to give us 2. Kind of got that from before, right? And then our change of y, right, is going to be the dy dx times that change of x. Okay, so you're multiplying these two columns together, and that should give us 1/2 or 0.5, however you want to write it. All right. And then x plus change of x and y plus change of y. Okay, so here we are going to get 0.25, comma, -1 plus 0.5 is going to give me a -0.5 on that first one. Okay, so that's there. Now we do this a second time, but we're going to use that new point. Okay, so here now when we plug in, I'm going to get -0.5 squared, and then 2 times the 0.25. So I'm plugging this point into the differential again. Plus 2, and that'll give me 0.625. Let's multiply these two together. And this gives me a 0.15625. And now we can add change of x, so I get that 0.5 that I want. And then do the -0.5 plus that 0.15625. And that gives me a -0.34375. Okay, if you write it as a fraction, you can say like f of 1/2 equals -11/32. And again, remember, this is only a BC question, okay? All right, and the last part of this is now we have to get the particular equation. And again, I'm going to rewrite our differential. And our initial point is 0, -1. Okay, so separate. Okay, integrate. Remember, you could write this as y to the -2nd, so you should get, you're adding 1, so -1 over y equals x squared plus 2x plus c. Let's use our initial point to find c first. So I have -1 over -1 equals c. So c is going to be 1. All right, now plug that back in right here. So we'll have -1 over y equals x squared plus 2x plus c. All right, if we flip the whole thing, you'll get a -y equals 1 over x squared plus 2x plus c, and then y is going to be -1 over x squared. Whoops. Make sure you put that 1 back in for the c. And that would be your particular solution.